Hey, ladies and gentlemen, Mrs. Hoekstra again, working on Lesson 10 of Module 1. I'm on page 38 of our book. Lesson 10, the title is Interpreting Graphs of Proportional Relationships. Okay, page 38. The essential question I've already typed in for us. What does the point 1r on a graph mean? And how is it related to the unit rate? All right, what does the point 1r on a graph mean? And how is it related to the unit rate? Okay, so that R, we're going to figure out what that is today and how it's related to what's going on in the unit rate. All right, example 1. Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies. I'm going to circle that. That seems like it might be important to me. 4 dozen cookies for 3 cups of flour. Okay, use this information to complete the chart. All right, so we're going to fill in this whole section here. Create a table comparing the amount of flour used to the amount of cookies. All right, so let's make a table. Let's scoot this down and let's make a table. We're going to keep track of what? The cups of flour. Right? How many cups of flour? This is measured in cups. And the cookies. Right? How many cookies we have. And this is in dozens. DZ for dozen. Okay? And so the first thing says I'm going to have 3 cups of flour. I get 4 dozen cookies. All right, well, if I keep that ratio, right? Keep that ratio going, if I double that recipe, right? I need twice as many. 6 cups of flour then would be 8. Right? What if I took the original recipe and I tripled that recipe? Then it would be 9 cups of flour and 12 dozen cookies. 144 cookies. It's a sucker to get fat. What if, let's just go really crazy, I do 9 times the original, right? So 3 times 9 would be 27 cups of flour. I'm making a huge batch. Maybe I work at a bakery. Right? And that would give me 36 dozen, right? Just this really big. We could do this to any set of numbers as long as that ratio stays the same. It's really vital when you're baking. Is the number of cookies proportional to the amount of flour used? Yes, right? This is proportional. Notice I am writing in a complete sentence. This is proportional. Because every single one of those values in that table, right, I could write them as a constant of proportionality. They would be 4 over 3, because remember this is y and that is x, and we always write the constant of proportionality as y over x, right? Always, 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 k is equal to y over x. So 4 over 3. Now I know some of you are going, hey, can I change that to a mixed number, 1 1/3? Yeah, you could, but I actually like leaving it in 4/3. 1, I'm kind of lazy. 2, it actually does give me information that I'm going to need to know, okay? But it does say, hey, let's change that over to a unit rate. So we're going to take that 4/3. And if I said, well, how many? I don't want 4 dozen cookies. I only want 1 dozen cookies, right? It's just Mrs. Hoekstra. I'm home from work. I'm hungry, but I don't feel like making 4 dozen cookies. I just want to make 1 dozen so I can just sit down, watch some television, cookies and milk, right? So I am actually going to take, 4 and divide by 3, right, on my calculator, and I would get 1.3 over 1, right, because I'm just dividing everything by 3. So in other words, I'm going to have 1.3 dozen cookies for 1 cup of flour. Maybe that's all I have in the house, right? I only have 1 cup of flour and I'm really hungry for cookies, so I can make 1.3 dozen. All right, next it says to model a relationship. What am I going to model? I'm going to model the data from the table. All right, now remember, I labeled flour as X and cookies as Y. So I will come down here and I'm going to put flour down here on the X-axis, right? And we're measuring this in cups. Make sure you label that, right? This is my X-axis. And my Y-axis over here on the side going up and down, that's going to be cookies. And we're measuring that in dozens. So always put those labels on there, okay? And then I'm going to count. Let's see here. What should I count by? Oh, I'll probably just count by ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you're going, Mrs. Hoekstra, you counted all of them, but you only wrote the evens. Yep, because I am that lazy. I did actually count by ones. I only wrote the evens down. I don't need to write them all down, but if you need to write them all down, please do so. All right. In fact, having that one there might be helpful. All right. And dozens of cookies. Again, I'm just going to count by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 up at the top. All right. Now take that data from that table, and we're going to start to graph it. Now flour is our X, so it's across the bottom. So I'm going to go to 3 on the bottom and up 4 right there on the cookies. There we go. 6 on the cups of flour and 8 right there is 8. 9 cups of flour. 9 cups of flour and 12 dozen cookies. Oh, I'm going to be off the screen now, right? I don't have enough room for 27, but if I did, do you think it would be on that line? Yeah, exactly. It'll be on that line. If I take my handy dandy straight edge from around my neck or a piece of paper or a ruler and I decide to connect these, right? If I connect these with a straight edge, it does seem to line up, doesn't it? And not only does it line up, but it also goes through 0, 0. That's kind of nice. And it makes sense to me. If I have 0 cups of flour, I have 0 dozen cookies. It's logical to me. So does the graph show that these two are proportional, right? That very next question. Yeah, the graph makes a straight line, doesn't it? Makes a straight line that goes through 0, 0, right? It makes a straight line that goes through 0, 0, so it's proportional. Right? We have a proportional relationship here. All right, last thing, we're going to write an equation that we can use to represent any number of cookies and flour. Any number. So what we're going to do is we're going to take that constant of proportionality up here, this one right here, and we're going to use it in our equation. All right, so I'm going to identify what my variables stand for. We can use any letters we want. I'm going to use C for cookies because I'm not very original when it comes to writing my variables. And I'm going to use F for flour, right? How much flour it takes. And according to this, I'm going to have the number of cookies is equal to 4/3 times the amount of flour, right? And then I can calculate how many dozen cookies I'm going to get for how much flour I have. All right? We use that off of the equations that we've learned earlier. Let's go to the next page. Let's over to page 39. Let's see here. Below is a graph modeling the amount of sugar required to make Grandma's chocolate chip cookies. So take a look at the graph. Let's not even do anything. What do you notice? I noticed that it made a line, right? And it goes through 0, 0, right? So I should know automatically that it is proportional. And of course, we just worked on it a minute ago. Data hasn't changed. So it makes sense to me. It says record coordinates from that graph onto the table. So we're going to go backwards from the problem we just had a minute ago. All right. So remember, your X is always on the bottom, right? And your Y is going up the side. When we write an ordered pair, it's always X comma Y. Always, always, always. Easy way to remember it. X comes before Y in the alphabet. X comes before Y in an ordered pair, right? There's an order that matters. Order matters. So that's why we put them in order. So in other words, we're going to keep track of the sugar and the number of cookies, right? All right. So if we notice our first ordered pair, of course it goes through 0, 0 right there, right? What's this one here? What is that one there? It appears to be 2, 3. 2 cups of sugar, for 3 dozen cookies. And I got another one right there. It looks like that one is 4, 6. Keep going up the line. Just follow from left to right. What do I have next? 8 cups of sugar gives me 12 dozen cookies. And what's that last one way up there at the top? That one way up at the top appears to be 12, 18. All right, Grandma has 1 remaining cup of sugar, right? She can only do 1 cup of sugar. So how many dozens of cookies can she make if this proportion stays the same, if that ratio stays the same? And it has to, otherwise your cookies don't taste right. So remember, that constant, or that unit rate, is always y over x. Well, what's the y in those ordered pairs? I don't want to use the 0, 0. It's not going to help me at all. But I like that one there. All right, so my y value is the x, is the 3. And the x value is the 2. Well, can we reduce that, right? It's improper. Do you want to think of it that way? How many times does 2 go into 3? It goes in there 1.5 times over 1. So in other words, Grandma is going to get what? 1.5 dozen cookies with 1 cup sugar. All right. Well, that point is also on the line because remember, this is y and this is x. I can rewrite this as an ordered pair, right? I can rewrite this as 1, 1.5. All right, so it looks like the one's up above it. Is that on the line, right? So let's go and find this point on that graph up here. So if I go over 1 to the right 1, up 1.5, is that point right there? Right, that's the point 1, 1.5. It is on the line. So what is the unit rate? Well, I just found it a minute ago. It was right here. So it's 1.5 over 1. Kind of already did that problem, so we'll just take it from above. All right, how many dozen cookies can Grandma make if she has no sugar? Underline, no sugar. I don't think those would be very good tasting cookies if she has no sugar. She doesn't have white sugar, she doesn't have brown sugar, she has nothing, right? If she has no sugar, she's going to have no cookies, right? What is that spot called? That point is called the origin. The origin. 0, 0 is always the origin. It is where the graph originates, hence the word origin. It's where it starts. Okay? All right, I want you guys to go over to page 40, next page over, and you'll notice it says exercise 1, and on page 41 it says exercise 2. I want you to pause the video, actually pause it, do those 2 problems, and then turn the video back on to check your answers. Okay, so if you've taken your time and actually tried these problems without cheating, right, you will notice that this first one is proportional because it is a line and it goes through 0, 0, right? The point 15.5, right, 15 gallons, find that on there, it takes 5 minutes of water, right? You're in the shower for 5 minutes. If you used 60 gallons of water, you had been in the shower for 20 minutes. All right, sounds like something my daughter would do. What are the coordinates for point A? Well, point A is at 30:10, which means 30 gallons of water were used for a 10-minute shower, right? So if you take a pretty fast shower like that, you used up, however, 30 gallons of water. Now remember, for the unit rate in the next question, we always write y over x. We always do the vertical over the horizontal first. So 10 minutes, I'm just using the data from above from the last problem. You could pick any of the 2 data sets, any of the data sets from above. 10 minutes, 30 gallons, reduce that to 1/3. That is my unit rate. I'm going to use the letter R for unit rate. R for rate just kind of makes sense to me. Put that on the graph. So on the graph, that is the point 1, 1/3. Okay? So if I go up there, you can see it on the graph. I put that little dot on there. It's really hard to see. And then my equation, I use T for time and G for gallons. Not very original. But I said T is equal to 1/3 G, right? The time you're in the shower is 1/3 the number of gallons. All right. If you need to pause that and make changes, go ahead and do that and then hit play again. But on exercise 2, I made my table, 0 people. It's not going to cost me anything to go to this carnival, right? To go to the amusement park. If I'm only going by myself, 1 person, $50. 2 of you, $100. Let's suppose you have a family of 5, it's going to cost you $250. Or let's suppose you're going to take your whole group of friends for your birthday, right? You're going to Great America and you have 10 of you, it's $500 for that. All right, this is proportional because the cost goes up the same amount for every person, right? Well, what is that unit rate? $50 per person, right? I did people divided by the cost. So I have those backwards, don't I? Oh, Mrs. Hoekstra. Let's go back and change that. I have these all backwards. Crazy Mrs. Hoekstra. There we go. I fixed those. All right. I have everything else, right? And then when I come down here and make my graph, right, I've got my number of people going across the bottom. I have costs going up the sides. I counted by $25. You could have counted by $100. You can count by $10. It's up to you. Just keep it consistent as you make the whole thing. It does make a line. My data's off a little bit, but it does make a line. And this is really super important. So if you struggled with this one, I understand. But it is really super important. I'm putting a star by it. I want to make sure that we all get this. So if you don't have it, please write it down. 0, 0, and 150 both must be on that line. They have to both be on the line. Not only does it have to be a line and go through 0, 0, but 150 also has to because that is the unit rate. 1 person, $50. All right. And then what does the 0.5250 mean? Well, it's 5 people are going to pay $250. All right, I know this was kind of a long video and a lot of work for you guys, but I know that you're going to get it and we're going to do great on this. I will see you all later.